All right, today we are talking about something really cool from Waymo. It's a new AI called SceneDiffuser, and it is completely changing the game for how you test self-driving cars. And it all boils down to one single, incredibly tough question. So let's think about that. How do you make a self-driving car safe enough for you and me? You have to train it for, well, for everything. And that includes those super rare, super dangerous scenarios. You know, the kind of event a human driver might see maybe once in their entire life, if they see it at all. Because here's the problem, right? You can't just send a car out to drive millions of miles and just hope that it runs into every weird situation imaginable. It's just not practical. It would take an eternity. You can't just wait around for a loose tire to come bouncing across a highway at the perfect, worst possible moment. No, you have to be able to create that danger whenever you want. And the only way to do that, really, is through simulation. You have to create a virtual world, a digital twin, where you can run millions of tests safely and super fast. And that brings us to the star of the show today, this brand new AI from Waymo that builds these virtual worlds in a way no one has before.
Okay, so first, let's just quickly frame the huge challenge that every single company working on autonomous vehicles is up against.
So at its core, simulation is really about creating a safe digital playground for the AI. It lets engineers throw literally countless situations at the car's brain. I'm talking everything from a simple lane change to a crazy, chaotic four-way stop intersection, all without putting a single real car on a real road. Now, the idea of simulation isn't new. Not at all. But actually creating simulations that are genuinely useful, well, that has always been incredibly hard. There have always been these major roadblocks in the way.
And it really all comes down to these three massive hurdles. First up, realism. I mean, if the virtual cars in your simulation don't drive and react like real, unpredictable humans, then the whole test is pretty much worthless. Second, the computational cost. Running these super detailed simulations over and over again takes a mind-boggling amount of computing power. And third, controllability. This one's tricky. How do you tell your simulation, hey, I need you to make a car swerve right about now without completely shattering the realism of the whole scene?
And this is exactly where Waymo's new AI comes into play. So let's properly meet SceneDiffuser.
SceneDiffuser is a type of AI called a diffusion model. We'll get into what that means in just a sec, but the simple version is it's one single, really smart AI that has basically learned the fundamental rules of the road. So it can do two things. It can generate a totally new, realistic traffic scene from nothing, and then it can actually press play and simulate how all the cars and people in that scene will move and react over time.
Probably the best way to get your head around this is to think about those AI image generators you've seen online. You type in a prompt, and it starts with this screen of just random static, right? Just digital noise. And then, step by step, it refines that noise into a sharp, clear picture. Well, SceneDiffuser does the exact same thing, but its canvas isn't a picture. It's a whole traffic scenario. It takes that digital noise and shapes it into the realistic movements of cars.
So let's dig into the first huge breakthrough here and see how this actually builds a better simulation. It's all about making the whole process way smarter and way more efficient.
See, the old way of running these simulations, we'll call it full replanning, is just painfully slow. For every tiny step forward in the simulation, the AI has to basically throw out everything it just thought of and replan the entire future for every single car, all over again. It's just wildly inefficient. But SceneDiffuser uses this new, lightning-fast technique called amortized diffusion.
And this chess analogy just nails it. The old method is like a chess player who, after every single move, completely forgets their strategy and reanalyzes the entire board from scratch. It's slow, and it leads to these jerky, inconsistent decisions. Amortized diffusion, though, is like a grandmaster. It has a long-term plan in mind, and with each new move, it just makes these small, smart adjustments. It's reusing its previous thinking, which makes it so much faster and a whole lot more consistent.
And you can literally see the results right here. On the left, using that old method, just look at how jagged and unnatural those projected paths are. That's what happens when the AI keeps hitting the reset button on its plan. But look at the right. With amortized diffusion, the motion is smooth, it's consistent, it's believable. It's how cars actually drive in the real world.
So what does all this add up to? A pretty huge leap, actually. This new method is 16 times more efficient. Let that sink in. It needs 16 times fewer calculations for every step it takes. And as we just saw, the quality isn't just maintained, it gets way, way better. Okay, so the simulation is now more realistic and way more efficient. But what about that third big hurdle, controllability? Well, this is where SceneDiffuser gets really, really powerful.
I mean, just imagine you're a developer and you can just type this, a simple sentence in plain English describing the exact dangerous thing you want to test against.
And boom, this is what you get. SceneDiffuser actually uses a large language model to understand that sentence and translate it into a specific set of commands. Then it generates a whole scene that's not only totally realistic, but also perfectly fits your request. This makes creating those 1 in a million dangerous scenarios, well, suddenly incredibly easy. But the control goes even deeper than that. The engineers can add what they call hard constraints, which are basically unbreakable rules for the simulation. So, for instance, they can tell the model to create a scene with one extra condition: no collisions allowed. On the left, you see a simulation where some of the cars might just phase through each other. But by adding that no collision rule, the model, on the right, is smart enough to adjust all the vehicle paths so they're still realistic, but now they're guaranteed to be collision-free.
And the level of realism it learns is just incredible. This chart here shows the length and width of thousands of real cars out on the road. That's the green cloud. And the blue cloud? Those are the vehicles generated by SceneDiffuser. They're practically identical. This means the model hasn't just learned how cars move. It's learned their actual physical size and shape.
And the data just backs it all up. This table puts the old method head-to-head with SceneDiffuser's new approach. Look at that. The new method gets a much higher realism score, which means it looks and feels more real while using a tiny fraction of the computing power. We're talking 96 calculations versus more than 1,200. So it's not just a little better, it is quantifiably, massively better, and more efficient.
So, we've seen the tech, but let's bring it all together and talk about why this big technical jump is so important for the future of self-driving cars. Here is the big takeaway. By making simulations faster and cheaper, Waymo can just run more tests. By making them more realistic, the data they get from those tests is better. And by making them more targeted, they can focus like a laser on the trickiest, most dangerous edge cases. Put it all together, and you are accelerating the whole process of building a safer and more capable autonomous driver. Which leaves us with this final thought. For so long, the biggest challenge was just finding or creating these rare, dangerous moments. But now that a tool like this exists, the challenge shifts. We now have the power to create any scenario we can possibly imagine. So the question becomes, what's the next thing we need to imagine?